Hi there, and welcome back to this channel. In this video, we are going to learn about the derivative of exponential functions. And we're going to be using these 7 questions for example, as an example on how to solve derivative of exponential function. Alright, so the standard formula that you should know is that if you are given that your function y is equal to e, that is exponential of f of x. Now your dy dx, the derivative of this your function becomes, you are going to differentiate the power, so you are going to take the derivative of the power f prime of x multiplied by e to the f of x. Is that clear? Then ln e. Now actually ln e, the ln e actually stands for log to the base of exponential. So log to the base of exponential is 1, right? So that gives you, so it means that this one is 1. So it means our formula is going to be this without the ln e. So basically, to find the derivative of an exponential function, you take the derivative of the power, then you now take the derivative of the exponent, is that okay, of the exponential. Now, if you take the derivative of exponential, what you will get is the exponential itself, the function itself again. Is that clear? Then, if you now take, if y were given to be a raised to power x, for example, then, or a raised to power f of x, so the same thing you're going to do, you will take dy dx will be equal to, you are going to differentiate this power, so you have f prime of x dot, you differentiate, by the time you differentiate this, you are going to just multiply with a raised to power f of x, and then the ln natural log of a. Exactly, natural log of the base. Natural log of the base. So let me take that again. We're going to have a, if you have a raised to power f of x, then your dy dx will be f prime of x multiplied by the function itself, then ln a. Is it clear? In this case, ln e gave us 1, so that's why ln e is not appearing there. Okay, so this a is going to be a constant. Is it clear? All right, let's apply that principle to those questions. So number one says we should differentiate that y is equal to 2 raised to power x. Okay, so following this formula, since we have a constant raised to power x, then we'll use this formula. So we'll first we'll differentiate that power. Derivative of x is 1 times, so dy dx will be equal to 1 multiplied by this function, the function itself, that is 2 raised to power x dot ln a. Ln a. Exactly. So our answer becomes dy dx is equal to 2 raised to power x ln a. And that is the answer. Alright. Then for number 2, we have y is equal to 2 raised to power 3x minus 2. Okay, in the same manner, we'll follow this formula. We'll first differentiate the power, which is another function. So we'll differentiate this, more like chain rule. Exactly. So we have dy dx will be equal to, we differentiate this, derivative of 3x minus 2 is 3, right? Dot derivative of, then we now have, we multiply it by the function itself, so we have dot 2 raised to power 3x minus 2, then ln a, so that will be ln the base itself, ln 2. Is it clear? So you can put this, so you can leave your answer like this, or put it in brackets if you want. Okay, so that's going to be our answer. All right. Then number 3 says that y is equal to 1 over e to the 4x. Okay, so following what we did here too, we are going to first differentiate the function. So before we even begin to differentiate, we are going to rewrite this function. So y becomes e to the minus 4x. So after writing the function, then we can now go by the formula. First differentiate the power. So dy dx will be equal to derivative of this. It's going to give us what? Minus 4. So minus 4 multiplied by, we are going to multiply by the function itself, which is this. So e to the minus 4x. Okay, then dot ln e. Now ln e, we said will give us 1, right? Or natural log of e will give us 1. So our answer becomes this. So we can write this as dy dx is equal to minus 4 multiplied by the time we rewrite this, it becomes 1 over e to the 4x. So that dy dx will be equal to minus 4 over e to the 4x. And that will be the answer. Is that clear? Alright, let's solve number 4. Number 4 says that y is equal to e to the root of x. Very simple. So we are going to differentiate this function on top here, okay? But let's rewrite this in a way that it will be simpler. So it becomes y equal to e raised to power x, which is now raised to power half. Is it clear? Power of power. Okay. So now what you do is, using power rule, you differentiate this. Okay, you differentiate this, and you can as well use chain rule as well. Make this guy equal to u if you want it. So you know what, let me use chain rule, then I'll show you how to just do it directly. So using chain rule, then we can say that let u be equal to x raised to power half, so that du dx will be equal to 1 over 2 x raised to power 1 over 2 minus 1 is minus 1 over 2. Is it clear? Minus 1 over 2. So here, we already have du dx. So since our u is already x raised to power 1 over 2, it means our y function has become e raised to power u. Does this make sense? So that dy du will now be equal to e raised to power u again, because the derivative of an exponential is that exponential function itself. So our dy dx using chain rule will now become du dx times dy du. Okay, so our du dx times dy du. So what is our du dx? Du dx gave us 1 over 2 dot, now this is equal to 1 over 2 times x raised to power minus half is 1 over root x. Does that make sense? So dot 1 over root x, then multiplied again by dy du, which is e raised to power u. So e raised to power u. Recalling that our u is x raised to power half, or root x. Do you remember that? Okay, so let's bring it here. So by the time we bring it here, we are going to have dy dx to be equal to e raised to power u, that is e raised to power root x, because our u is root x. So e raised to power u all over 2 root x. So this will be the answer. Alright, so that's our dy dx. Then the fifth question, number 5, says y is equal to e raised to power 6x squared plus 7. Alright, simply go by the formula. Differentiate. Okay, I said I was going to show you how to go directly. Now look at this. Y equal to e raised to power root x. Simply do this. Differentiate this. It's going to give you, remember that this is already x raised to power 1 over 2. So you bring 1 over 2 down by power rule. 1 over 2 x raised to power minus half, that's the derivative of this, okay, dot derivative of this will give you e raised to power root x again. Does that make sense? Okay, so if that's the case, then you already have that this one is going to be under, so you have e raised to power root x over 2 root x. Do you see that? So you need not really go through all of those stress. So, but if you don't understand, you can always do it. Alright, so we have this. So dy dx is equal to, differentiate this function. So I'll just go directly differentiate this function. It's going to give us 12x, okay, dot the function itself, e to the 6x squared plus 7, then ln e. But since there's no ln e there, we just, since ln e is 1 rather, then we just, it won't appear. So dy dx will now become 12x e to the 6x squared plus 7. It doesn't change, so that's our answer. Alright? Okay, let's go to number 6. Number 6 says that y is equal to x raised to the power 4 plus 1 e to the 2x. Okay, so now this is product, so we know that we are going to use product rule, and remember product rule says that u v prime plus v prime u prime v, right? That is v u dv dx plus u v du dx. Okay, so what that means is that very simply we'll just, if you don't understand, you should see my video on this, product rule. So hold this and differentiate this, or differentiate this first and hold this, either way you want to do it. So what I want to do is I will hold this and differentiate this. If I hold this, I'm going to have my dy dx will be equal to x raised to the power 4 plus 1. I'll hold this, differentiate this. Derivative of this is going to give me, remember that I'll first differentiate this guy. If I want to differentiate e to the 2x, I'm going to differentiate this top first, which will give me 2. Then this dot means multiplication. Then I'll have the function itself, which is e to the 2x. Now plus, so this is now v du dx, okay, or u dv dx, either way. So then I'll now hold this and differentiate this. So let me hold this, that's 2x dot, let me differentiate this. If I differentiate this, it's going to give me 4x cubed. So I have 4x cubed. I hope that is clear. Then dy dx will now be equal to 2e to the 2x. Okay, if you notice, e to the 2x is common, right? So we can factor it out. 2 is also common. 2 is also common. So we can factor out 2e to the 2x into bracket. By the time we bring out this guy, it will remain x to the 4th plus 1. Then we bring out this guy and 2, it remains 2x cubed plus 2x cubed. Let's arrange it in order. It becomes 2x cubed plus 1. So this is going to be the answer. We rearrange, exactly. It's supposed to be 1 first, but I rearranged. Alright. So then number 7, which is the last one. We have y is equal to e to the x sine pi x, okay? So we have to find dy dx. So dy dx will be equal to, we'll hold this, differentiate this, then hold this, differentiate this, because this is also product, right? So let's hold this. So that will be e to the x dot, let's differentiate this. Now if you want to differentiate this, you have to first differentiate this guy, and derivative of pi x is pi dot, then differentiate the entire function itself. Sine pi x will give you what? Cos pi x. Does that make sense? Then plus, hold this, differentiate this. That will be sine pi x and differentiate this dot e to the x. Is it clear? Okay, so from here, dy dx will now be equal to e to the x pi cos pi x plus e to the x dot sine pi x. Okay, is there anything you can do? E to the x is common, so we can say e to the x into bracket pi cos pi x plus sine pi x. So this will be the answer for dy dx. Okay, so that will be the answer. You can contact me on WhatsApp for more questions on this if you want to test yourself. I have questions that have been resolved with answers, so you can contact me on this is my WhatsApp number, and I'm going to send you those questions to help yourself out. If you don't get them, I'm going to send you the calculations, the workings. Right? God bless you as you subscribe to the channel and share the videos.